friends, and welcome to a short video about adding and subtracting polynomials. Now when we add and subtract polynomials, what we look for are like terms. Like terms are categorized by their variables. So the variables need to look alike. We also need to keep in mind when we're subtracting because it could really mess us up. I love to color code this stuff, so if you have color coding to do or things to use to do color coding with, I suggest you do that when you do adding and subtracting polynomials. It adds color, which is fun. And it helps you do the math too, but fun. Let's get started. I like to begin with the highest exponents because you will eventually need to organize your polynomials in descending order, meaning highest to largest to smallest exponents. All right, so the largest exponent I see here is x to the third. I don't see any other x to the third, so I'm moving on to x to the second. Here's this one, and this one. And then I have my lonely minus 3. It's okay, minus 3. I'm going to begin with x to the third because that's the largest exponent. We're going to combine the two green colors you see here. 5 plus 2 gives us 7x squared. And we end with minus 3. Next problem we have here is subtraction, so we've got to be careful. Still beginning with highlighting. The largest exponent is n to the third, so I'm going to highlight the n to the thirds. And then I'm going to highlight the ones without variables because that's all I have left over. Okay. 2 minus 5 gives us negative 3n to the third. 4 minus 2, 2. Fantastic. Let's move on. Ooh, lots more terms. Maybe more colors? Ooh, we'll see. The largest exponent I have here is k to the fourth. Then I have a k to the second. And we finish off with no variables, no k. No k. All right. We are adding. So, negative 4 plus negative 3, negative 7. 3 minus 14, or 3 plus negative 14, negative 11. And 14 plus negative 8, positive 6. Oh, it looks like this one has a lot of terms too. So, the largest power I see here is again to the fourth. Beautiful. Then I have n squared. And let's finish off with just a regular n. Let's begin subtracting. All right, subtracting. Let's be careful. Negative 2 minus negative 6 leaves us with positive 4 n to the power of 4. 13 minus negative 13, positive 26 n squared. Lastly, 11 minus negative 3, positive 14n. Okay. Let's keep, whoa, look at that one. Created this worksheet and I get surprised at it as if I didn't, but maybe that's just how nerdy I am. All right. So, as you can tell in this problem, we have a lot of variables, and these variables are paired up in different ways. In order to combine like terms, we need to make sure that the variables look exactly alike. Exactly. The way I like to organize these types of polynomials is by the letter that comes first in the alphabet. So in this case, that's our x. The largest power of x I see here is x to the fourth. I see it happening twice though, right here and right there. I'm going to give this negative 8x to the fourth, y to the fourth, its own color first. And we will look for more of those. Are there any other x to the fourths, y to the fourths? Unfortunately, I don't see any. So I'm going to continue to the other x to the fourth, which has a smaller power of y, as y to the third. Are there any others? I see this one. That looks like that's it. Let's move down the powers of x, and that would be just a regular x to the power of 1, and it has a y to the power of 3. Here's another one. Is there a third one? Yes, there is. And then we have this guy, 7y to the fourth. That's going to go last. Okay, I'm beginning with the largest x and y exponents. Now let's combine the blue ones. Negative 9 plus 3, that's negative 6. Next, I'm looking at the green ones. Negative 9 plus 3 is negative 6, plus 2 is going to be negative 4. And then on the tail end, I'm putting that pink highlighted term that was all by itself. Okay, not too bad. Very pretty. Ooh, okay, so here's our last one. I hope that after we finish this one, you'll feel a little bit more comfortable about adding and subtracting polynomials. If not, happy to answer any questions you post in the comments, or if you have a teacher to go to, it's probably a good idea to ask them. I'm going to begin this one the same way as I did before. I'm going to look for the highest power of the letter that comes first in the alphabet. In this case, that's the letter U. U. You, me, you, us. All right, I'm done. Sorry. As long as I can make myself laugh, life is good. There are no other u to the fourths to highlight for me, so I'm going to move on to u to the thirds. So I see a u to the third, v to the fourth. I'm going to highlight any other u to the third, v to the fourth that I see. Okay. Okay, perfect. Are there any u squareds? There are. Where's this guy? Any others? Nope. But we do have regular u's. Now before I begin adding, subtracting, whatever I need to do, let's keep this in mind. We're subtracting and adding here. I'm going to begin with the yellow color. We have a plus and a minus. That doesn't change anything. Negative u to the fourth v squared. Okay. Now I'm going to move on to the blue. I'm going to be very careful because it's in 3 different places. Negative 5u cubed v to the fourth minus negative 5u cubed v to the fourth. It's actually 0. So we're left with 8u to the third v to the fourth. Okay, next we have u to the second. Notice, however, that u to the second is in the parentheses that's after the minus sign. This is going to be a negative 8u to the second v to the second. And I'm going to finish this off by combining the pink ones. 9 minus negative 8u is going to give us positive 17u. Fantastic. I hope this was helpful. If not, so sorry. Anyways, have a wonderful rest of your day, whatever it is you're doing, night, afternoon, whatever time of day. I'll see you in the next video.